Let's continue our lesson of graphing piecewise defined functions with an example with more than two cases. Here's the example. The rule of the function is 2x minus 3 for x less than equal to 2. It's 1 over 3 minus x for x between 2 and 3, and it's x minus 2 for x bigger than equal to 3. So notice that the domain of the function is negative infinity and infinity, because if you put in the intervals that you have here, which correspond to negative infinity and 2 included, 2 and 3 open, 3 closed, and infinity, they add up to the entire real numbers. Cutoff points, oh, look, there is a 2 in here that cuts off everything below. Then it shows up to the next rule, and then another place that it cuts off is a 3 and shows up in the next rule as well. So we have the plane. Let's use our cutoffs to actually graph the function. And here, so first thing, we put in the two vertical lines. One vertical line at x equal to 2, another vertical line at x equal to 3. Now, graph each piece in the correct strip of the plane. And so this one goes to here, this one goes in the middle right here, and this one goes right here. So that's the first one, y equal to 2x minus 3, and that's the second one, and that is the third one. Okay, so the last step is to go and figure out where the cutoff x is equal to cutoff happened, or if it didn't happen at all. Here it happened at x equal to 2, and it happened in the first piece. X equal to 2 happened in the first piece, and x equal to 3 happened in the last piece. So what do? First, we put a field circle for x equal to 2, and the y value plug in here. So we plug in 2 times 2 minus 3, and that would be 1. It should be right here. And and then we put in the other one, which is 3, and incidentally 1, because if I plug in 3 in here, I get 1. Now, do I get any open unfilled circles here? No, because this red one over here, which was part of the first rule of the function, first piece of the rule of the function, also was sort of an endpoint for the blue part of the function. Therefore, there's no, the endpoint of the blue one does not have to be an empty circle. And then the other endpoint is, again, as we approach x equal to 3, the second rule of the function approaches infinity. Therefore, there's no endpoint here to put an empty circle in there. And then the other end also is a fill circle. Now let's start this example. This example is again 3-piece or 3 different rules for the function, but 2 of them are intervals, x less than 3 and x bigger than 3, but the one in the middle is not an interval. So what's going to happen here is that we graph. First, we find the cutoff. In this one, cutoff is going to be only 1 point because we don't have intervals. In the second rule, we only have a number. So let's graph as if the second rule doesn't exist. Okay, so here if the second rule didn't exist, we would have this piece and this piece and two empty circles here. And then since second rule exists, we're going to put in the value of the second rule, which is 3 and 4. So that's the point field, 3 and 4. So that's another one. Um, so let's talk about some natural piecewise defined examples. This is a natural piecewise defined example. If you see f of x equal to 1 over x minus 2, you know that the domain does not include 2. So you will have two intervals in the domain, the union of two intervals. So when you're writing it up, it's going to be x less than equal to 2 and x less than 2 and x bigger than 2. So these are one of the naturally defined piecewise function. In here, another example, if you have g of x equal to absolute value of x minus 2, then this can be, or absolute value of anything, it can be written as a piecewise defined function. So for values less than 2 inside, less than equal to 2 inside is going to be less than equal to 0. For values bigger than 2, the inside of the absolute value is going to be bigger than 0. And so when so I can put it into two pieces. If the value, if x is less than equal to 2, x minus 2 is going to be negative. So I have to, g of x is going to be negative of x minus 2. That's actually 2 minus x. When x is bigger than 2, it's just going to be x minus 2, and that's x minus 2. That equal sign, if you notice, it could be on either of them or it could be on both of them in this specific case. And this is how you graph it. So in the quizzes, you will see some of these examples. And that's the last one. And please do your quizzes.